Hello from the Tin Man. Okay, our little pulse motor's going to be doing a bit of an experiment tonight. Now this discussion question goes back quite a way, and it's in regards to the high voltage spikes coming off the pulse motors going back into the charge batteries. With this setup I have one run battery and I've hooked two 12 volts in series to give us 24. We're at 24.4, around that, so they are quite low. Now it's been said by some members that the high voltage spike coming off the coil will go into our charged battery positive, and that high voltage will travel all the way through the battery. And there was some of us that believed, including myself, that high voltage spike with such a low current would simply be squashed by the battery and would not be going through the battery. So what I've done here, in between the two charge batteries, I've put a 240 volt neon. I also have a jumper, and this is to see if the high voltage actually does travel through the batteries. Now what it's going to have to do here, with these two batteries being in series, that being the start of our run coil and our high voltage spike coming off the collector through the diode, which is also the end of our run coil, goes in here. So it's actually going to have to travel from this positive plate through the battery to the negative plate, back to the positive plate, through this battery, through the negative, into the negative plate, and to the start of our run coil. So the voltages actually have to, the high voltage will actually have to travel through two batteries, which makes it even a little harder for it to make the grade. So in theory we should be able to disconnect this jumper between these two batteries, and this neon should indeed light up along with the one between the collector and the emitter. Now another thing, just for interest, the guys that are building this, I just so happened to come across some Darlington transistors, as you would have seen in my last video, and the performance of these is excellent. They seem to switch on really hard and really clean, and they switch off very quick as well. This will run over 600 milliamps. I've had it going for up to an hour, and this transistor stayed as cold as this aluminium block. Even without it being on an aluminium block, it does not get hot. Normally with over half an amp going through them, they will start to get warm. These ones do not. They switch on hard and fast, and they switch off hard and fast, so give them a try. But anyway, back to this little experiment. There have been guys building these pulse motors for a long time, and a member by the name of Twally spent a lot of time making a lot of videos showing us different tests. One of the tests he called the 1 ohm test, and tried to explain how the high voltage is actually travelling through the battery. And there was those of us, like I said, including myself, that believed the battery was just squashing that high voltage and reducing the battery, or reducing that voltage to slightly higher than the battery but increasing the current. So what we'll do now is we're going to hook her up and give her a little spin, and away she goes. Excuse me. Like I said, this one pulls about 617 milliamps at 12 volts. but it charges really good. Now it's charging 24 volts and they're going up pretty quick. So anyway, what I'm going to do now is disconnect the jumper between these two batteries and we'll see neon come on. Hopefully we will. Like that. Now if the high voltage was actually travelling through the battery and actually travelling through this one as well, this neon should come on once I disconnect this jumper. We should have the high voltage going in there, coming out of here, and this being the other end of the circuit, of course. The start of our one coil should go through the battery, come out the positive. So we should in fact get the high voltage between the two batteries, and that would answer a lot of questions. So we'll disconnect it and see what happens. And there you go. They are, like I said, 240 volt neons. So that just goes to show you that I and some others were very wrong. The high voltage does in fact travel through the batteries, and in this case it's actually travelling through two batteries to light that neon up. So Twally, you were definitely correct, and this also gives reason for me to give JB and his work a little more credit than I have been giving him. Now another thing that's come about with this is, I've always said, if you want a nice steady amp reading of what's going in your charged battery, you simply put your amp meter between these two, your run and your charge, instead of the jumper. Put the amp gauge in there and that will give you your amp readings. But the problem with that now is, now that we know there's over 240 volts travelling through these batteries, are those amps to be read as the 240 volts, or as the voltage of the batteries, or a combination of the both? So this would be one reason why it's very hard to accurately measure the amperage going into your charged battery, because there is definitely a high voltage travelling right through that battery, and in this case also through this battery. So there you go. I have set about to prove myself wrong, and I've done that. And another good reason why it pays to take in what people say that have been doing this sort of thing for a long time. So there's the answer I have been waiting for, and a lot of other members and maybe new members. If this light globe test isn't enough for you, take the globe out, disconnect the jumpers and put your fingers on those two terminals and see what happens, because I've done it, and it's a little bit more than a tickle. So there you go. That's answered my long asked question, and has corrected me in the way that I now think about what is actually happening inside those batteries and how these systems actually work. Okay, well, our batteries are charging very nicely. The machine runs very well, and I have found an answer to a question that I've long been asking and debating. Cheers from the Tin Man.